Hello, I'm Seema and welcome to part 18 of the chapter Solutions. We were discussing colligative properties and in part 17 I explained the second colligative property to you, that was the elevation in boiling point. Let us now solve a few numerical problems in order to understand this concept better. This is question 2.7. It is the solved example of your NCERT textbook. The question reads, 18 grams of glucose is dissolved in 1 kg water. At what temperature would water boil? At 1.013 bar, which is 1 atmospheric pressure, where Kb for water is given, which is 0.52 Kelvin kg per mole. We know that delta Tb, according to this molar elevation thing, delta Tb is equal to Kbm, where Kb is the molar elevation constant or the boiling point elevation constant, and m is the molality of the solute. Let us see what all is given to us. 18 grams of glucose. So glucose is your solute, right? So glucose, which is C6H12O6, would form component 2, and water, which is your solvent, would be component 1. So 18 grams of glucose, we know the mass of glucose, that is W2, is equal to 18 grams, right? And 18 grams of glucose is dissolved in 1 kg water. So W1 is equal to 1 kg, which is 1000 grams. Because this is given in grams, so we write the kg in grams also. So is in 1 kg of water. At what temperature will water boil? At 0.013 bar. Kb for water is given. Kb is given, which is equal to 0.52 Kelvin kg per mole. Right? Now, what is required? The elevation in boiling point would be equal to Kbm, which is the molality. And what is molality? Molality is the number of moles of the solute present in 1 kg of the solvent. And we've been told that the solvent, that is water, is already 1 kg, which is 1000 grams. So this part is already done. We have been given the weight of glucose, so in order to find out the molality, we must have the number of moles of glucose. And if we have number of moles of glucose, 18 grams is present in 1000 grams, we need the number of moles present in 1000 grams. So if we just calculate the number of moles, that would be the molality of this solution. So in order to calculate the number of moles, what is number of moles? Number of moles is equal to mass upon molar mass of anything. Since you're talking of glucose, it is W2 upon M2. So we need to calculate M2. Glucose, the formula is C6H12O6. So M2 can be calculated from this. There are 6 atoms of carbon. The mass of one atom of carbon is 12 into 6 plus the mass of one atom of hydrogen is 1, and how many atoms are there? 12, plus the mass of one atom of oxygen is 16, and how many are there? There are 6. So when you find out the sum of all this, the molar mass of glucose comes out to be equal to 180 grams, 180 grams per mole. So from this you can calculate the number of moles. The number of moles present in 1000 grams. So the number of moles would be W2 given to us as 18 grams. So N2 would be equal to W2 upon M2, which is equal to W2 is 18 upon 180, which is equal to 0.1, right? 0.1 mole, molar solution. And since the number of moles is this 0.1 mole, it is present in 1 kg, so the molality is also 0.1. So molality is also equal to 0.1. And in order to find out the elevation in boiling point, delta Tb is equal to the Kb into molality. We've calculated molality and Kb is given to us. Kb is 0.52. 0.52 Kelvin kg per mole into 0.1 mole per kg. Molality, what will be the units of molality? It will be mole per kg. So the kg and kg will get cancelled, mole and mole will get cancelled. You'll have the answer in Kelvin. So 0.52 into 0.1 would be 0.052 Kelvin is the elevation in the boiling point. Now what is the boiling point given? That at what temperature would water boil at 1.013 bar? In this solution, now the water at the elevation is 0.052. We know that water boils at what in kelvins. At what temperature does it boil at 1 atmosphere or 1.013 bar? The boiling point of water is 373.15 Kelvin. And this is the increase in the boiling point. So you will add this 0.052 Kelvin. So the boiling point now would be equal to, final boiling point would be 373.15 plus 0.052, which will come out to be equal to 373.202, which is equal to 373.202 Kelvin would be the boiling point of water. So this was question 2.7. So let's now do question 2.8. The question reads that the boiling point of benzene is 353.23 Kelvin. When 1.80 gram of non-volatile solute is dissolved in 90 grams of benzene, the boiling point is raised to 354.11 Kelvin. You have to calculate the molar mass of the solute. Kb for benzene is given to you. So let us first write down what all is known to us. The boiling point of benzene is 353. It means in the pure form, boiling point is Tb naught is 353.23 Kelvin. Right? And when 1.80 gram of the non-volatile solute, it means W2. Solute is 2 and the mass of solute is given 1.80 gram is the mass of the solute. When 1.80 gram of a non-volatile solute is dissolved in 90 grams of benzene. So benzene is the solvent. So W1 is given to us is 90 grams. Okay. And the boiling point is raised. So the boiling point of benzene is raised. So Tb final would be is raised to 354.11 Kelvin. So we see that Tb naught and Tb are given to us. Therefore, we can calculate delta Tb from this. So let us read the rest of the questions. You have to calculate the molar mass of the solute, that is M2 is to be calculated. And Kb for benzene is given. Kb is also given to us, which is equal to 2.53 Kelvin kg per mole. Right? So now we know what all values we have. Let us see what is the formula that we use. We know that delta Tb is equal to Kb into M, where M is the molality of the solution. And how do you calculate molality? So we can expand this. So delta Tb becomes equal to Kb. What is molality? Molality is the number of moles of solute present in 1 kg of the solvent. So number of moles of solute. How would you calculate number of moles? Number of moles of anything is the mass of the substance divided by its molar mass, right? So the mass of the substance, that is M2, here is W2 is the mass upon molar mass would be M2. That will give you the number of moles of the solute present in 1 kg of the solvent. But the solvent, what is the mass of solvent given to us? 90 grams. So it means that W2 upon M2 is the number of moles present in 90 grams. So in 1 gram, in 90 grams, the number of moles present is W2 upon M2. In 1 gram, it will be upon 90 grams. And in 1000, in 1 kg, how many grams do you have? 1000 grams. So in 1000 grams per kg, you will have into 1000 grams per kg. So now what is asked? We've been asked M2 and delta TB can be calculated from this. So let us find out delta TB. Delta TB would be equal to what is delta TB in elevation of boiling point? The final boiling point minus the initial boiling point. So what is the final boiling point? TB is the final boiling point minus T0B is the initial boiling point. So let us write down TB is 354.11 Kelvin minus the initial boiling point is 353.23 Kelvin, and this comes out to be equal to 0.88 Kelvin. Right? Now you to find out M2. So switch delta TB and M2 and you get the formula for M2. So M2 would now be equal to KB into W2 upon delta TB into 1000 grams per kg upon 90 grams. Right? And let us now substitute the values. KB is given to us, which is 2.53 Kelvin kg per mole upon into W2 is 1.8 grams upon delta TB is 0.88 Kelvin into you have 1000 grams per kg and 90 grams of the solvent given to us. Now solve this. Let us first take care of the units. The gram and gram gets cancelled. The Kelvin and Kelvin here gets cancelled. Kg per kg gets cancelled. Since you're looking for calculate the molar mass. So molar mass of the solvent should be in grams per mole. So you have per mole here and grams here. So grams per mole should be your unit. So that is right. Grams from here and per mole from here. So that will be your unit. And when you solve the numerical part, what is the answer that you get? You get it is 58 grams. 58 grams per mole is the molar mass. Now let me solve one problem which is your in-text question, and then I'll wrap up the video. Give me a moment to write it down. Okay, so now this is question 2.10, that is an in-text question. The question reads, boiling point of water at 750 millimeter mercury. We know what is 1 atmospheric pressure, 760 millimeters of mercury. So this is less than an atmospheric pressure. And boiling point of water at 760 millimeters of mercury is 100 degrees Celsius. But at a lower pressure, water boils at a lower temperature. So the boiling point of water at 750 millimeters of mercury is 99.63 degrees Celsius. How much sucrose is to be added to 500 grams of water such that it boils at 100 degrees Celsius? Kb is equal to 0.52 Kelvin kg per mole. Now again, what all is given to us and what's the formula that we are looking for? The formula that we are looking for is delta Tb is equal to Kbm, where m is the molality. So let us first see what was given to us. The solvent is water, so that is 1, and solute, that is sucrose, that is component 2. So the boiling point of water at 750 millimeter mercury, that is Tb0, is equal to 99.63 degrees Celsius. And how much sucrose is to be added to 500 grams of water? So water is 500 grams, which means W1 is equal to 500 grams of water such that it boils at, and Tb now, the water after adding sucrose is Tb, the boiling point is 100 degrees Celsius is what you want, the desired. And Kb, we know in the question, in the textbook, the Kb value is not given to you on purpose so that you refer to the table as scientists do and you get the value from a table. And that is just a little practice of how when scientists work, they really don't have these values. They have to refer to the tables to get these values. So that is sometimes done on purpose to give you a taste of what it is like. But otherwise the value of Kb is 0.52 Kelvin kg per mole. So Kb for water is Kb is equal to 0.52 Kelvin kg per mole. Now, in order to calculate the molality, what are you supposed to do? We know that molality is the number of moles of the solute present in 1 kg of the solvent. So what's the formula for number of moles? Number of moles is the mass of the substance divided by molar mass. So the mass of the solute would be W2 and molar mass of solute would be M2. Present in 1000 grams or 1 kg of the solvent. We've been given the what is the mass of the solvent? 500 grams. So in 500 grams, this is the number of moles present into 500. So in 1 gram it will be upon 500, and in 1000 grams it will be into, this will be into 1000 grams per kg, and this is in grams. So that gives you the molality. So you get delta TB becomes equal to Kb into W2 upon M2 into 1000 grams per kg upon 500 grams. Now how do you calculate the molar mass of sucrose? The formula to calculate molar mass of sucrose, the formula of sucrose is C12H22O11. The mass of carbon is 12 and there are 12 atoms of carbon, so 12 into 12, plus the mass of one hydrogen is 1 and there are 22 hydrogens into 22, plus the mass of oxygen is 16 and there are 11 oxygens. So when you find out the sum of all of these, you will get the molar mass of sucrose is 342 grams per mole would be the molar mass of sucrose. Now let us substitute all the values and find out, okay, before we come to that we need to find out TB, delta TB. Delta TB, as in the previous problem, is TB, that is final boiling point, minus initial boiling point, because you're looking for elevation. So final boiling point is 100 degrees Celsius minus initial boiling point is 99.63 degrees Celsius. Now look here. For all numerical problems, we usually use Kelvin temperature in Kelvin. But here we are only looking for a difference in the temperature. And the size of 1 unit of temperature is the same, whether it is, or the magnitude of 1 unit of temperature is the same in either Kelvin or in Celsius. Therefore, in order to find out the difference, we need not convert the temperature to Kelvin and then solve our numerical problem. So here we are just looking for a difference. What is the difference? How many degrees of difference lies between them? So that can be done just by keeping it in Celsius. So when you do this, this comes out to be delta TB would be 0.37. 0.37, now you could call it Kelvin. Why? Because whether it is Celsius or Kelvin, the difference is the same, but in the numerical problems, we use Kelvin as the temperature. So either you convert this to Kelvin and then find the difference, or just find the difference and put Kelvin in place of it. So now we have the value of delta TB, and what are we expected to find out? How much sucrose? We are expected to find out W2, which is not known to us. So rearranging this formula now, this equation. Now what would W2 be equal to? W2, if you keep it here, what would you get? Delta TB, everything else goes on this side. So W2 into, these two go up, into M2 into 500 grams upon Kb comes down, and we are looking for W2 into 1000 gram per kg. Now substitute the values. Delta TB is calculated is 0.37 Kelvin into M2, molar mass was 342 grams per mole, and into 500 grams divided by the value of Kb is 0.52 Kelvin kg per mole, right? So the per mole get cancelled. Wait, first let us write this into 1000 grams per kg, right? The kg and per kg get cancelled. Since you're looking for weight, the mass, your answer should come in grams. All other units should go away. So This gram and 1 gram go away, you're left with just this gram. And that's the right unit. The Kelvin and Kelvin here would get cancelled. So now when you solve this, you'll arrive at the answer that you're looking for. And this comes out to be 121.67. So this is equal to 121.67 and grams would be the answer to this problem. So I hope with these numerical problems, this concept of the second colligative property, that is elevation of boiling point, is done and you would have understood it well. So practice more problems and that will help you deal with your examinations. And if you found this video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching and bye-bye for now.